I've pre-drawn some molecules here. Let's see if we can use what we know to name them. So what do we have? This first molecule right here, I have a bunch of rings. This is a 1, 2, 3, 4, 5, 6 carbon ring. These are each 4 carbon rings. 1, 2, 3, 4, 1, 2, 3, 4. So the largest ring is essentially going to be our backbone. So it's going to be this 6 carbon ring right here. 1, 2, 3, 4, 5, 6 carbons. So that is a cyclohexane. Cyclohexane. All double bonds. That's why we get the ane. 6 carbons hex. It's in a cycle, cyclo. And then we have 2 of these 4 carbon rings. So 4 carbons, we're dealing with the prefix but, but for 4. And we've got 2 of them. So both of these are butyl groups. Both of these are butyl groups. Both of these are butyl groups. But they're in a cycle, so they're actually cyclobutyl groups. Cyclobutyl. Cyclobutyl. And we have 2 things attached to this ring right there. And if you only had one thing attached to it, you wouldn't have to number. But when you have 2 things, you start numbering at one of them. So let's say we start numbering here. And you go in the direction so that the next group has the lowest number. So in this case, we want to go in the counterclockwise direction. If we went this way, it'd be 1, 2, 3, 4, 5. This guy would be a 5. If we go in the counterclockwise, it'd be 1, 2, 3. This guy will only be a 3. So this right here, we have 2 cyclobutyl. So it's dicyclobutyl. It is dicyclobutyl. Dicyclobutyl. We have 2 of them, and they are at the 1 and 3 position. So at the 1 and 3 position, I have 2 cyclobutyls on my cyclohexane, I guess you could call it main ring. Let's try this one right here. So I have a 5 carbon ring, 1, 2, 3, 4, 5 right there. And then I have a, let's see, 1, 2, 3, 4, 5, 6 carbon ring right there. So this is going to be the main ring. That is a cyclohexane. Cyclohexane has 6 carbons on them in a cycle, all single bonds. And attached to that, I have a cyclopentyl group. YL for the group. So this is a cyclopentyl group on it. We don't have to number it because it's only one group attached to the main ring. If there was another group, we would have to number it like we did up here. So this is cyclopentyl. That's this part right here. Cyclopentyl attached to cyclohexane. Cyclopentyl, cyclohexane. Now let's try this one over here. So the first thing we want to do, there's no cycles here, but we have to identify the longest chain. To do that, let's just count it out. It could be 1, 2, 3, 4, 5, 6, 7. It's not the longest chain. Maybe it's 1, 2, 3, 4, 5, 6, 7, 8. That looks like the longest chain. So let's make that the longest chain. Let's make that the longest chain right over there. Make that the longest chain. And we want to start numbering in the direction so we encounter the first attached groups first. So we do want to start numbering down here because we have groups attached right on the 2 carbon. If we started over here, we would have to go pretty far until something's attached. So we go 1, 2, 3, 4, 5, 6, 7, 8. So we know we're dealing with an octane, all single bonds. It's not a cyclooctane. It's not in a cycle. So we know we're dealing with an octane. We know we're dealing with an octane. And now we just have to add the groups to it. So what do we have here? What do we have here? This right here is just one carbon attached to the main chain. This is another carbon attached to the main chain. So both of these right here are methyl groups. Meth is for one carbon. Those are methyl groups. Now we have, if you look at all of them, these are the only methyl groups. These 2 up here aren't methyl groups. So we have 2 methyl groups on our entire chain. So it's going to be dimethyl. And they're both of the methyl groups are at our 2 positions. So this is going to be 2, 2 dimethyl. This part right here is 2, 2. That right there is 2, 2 dimethyl. We're going to decide what order to write it in after we figure out what these are called, because it has to be in alphabetical order. So this is 2, 2 dimethyl. The whole chain is an octane. What are these over here? Well, these, how many carbons? How many carbons do we have here? 1, 2, 3. They actually look the same. We have 1, 2, 3 here. We have 1, 2, 3 there. So these are both propyl groups. These are both propyl groups. isopropyl groups. And if we deal with common names, this is kind of that Y shape. You could call it sec-propyl because this carbon right here that's attached to the main chain is attached to two other carbons. But the more common one, because this part forms this Y shape, is isopropyl. It's isopropyl. And we have two isopropyl groups. These are both isopropyl. So we would want to call this, let me actually, so we have two isopropyl groups. So we would have diisopropyl. Let me write this. Diisopropyl. Diisopropyl. And they're occurring at the 4 and 5 positions. Two isopropyls at 4 and 5. So this is 4 and 5 diisopropyl. That's that group and that group right there are accounted for with this. Now we have to just figure out the order that we write it in. You ignore the di or the tri out front, and you just look at them in alphabetical order. So we have an I for isopropyl. We have an M for methyl. Let's write the isopropyl first. And I've actually seen some people want to go for the P, but the main thing I ignore is just the di or the tri in front of the isopropyl. You shouldn't involve that, but everything after that you do involve. So I'll write the isopropyl. I'll write the isopropyl first. I comes before M. So this is going to be, if we were to write the whole thing, this is going to be 4, 5 diisopropyl, diisopropyl, 2, 2 dimethyl, 2, 2. Actually, this should be a comma here. 4, comma 5. Let me scratch that out. 4, comma 5 diisopropyl, 2, comma 2 dimethyl, octane, octane, octane. And we're done. But this was just the common name. You might remember that, when we do with iso or sec or tert, butyl or propyl or whatever, that's the common name. If we want the systematic name, we can look at we could start at where we are attached to the main chain and view that as 1, and then make the longest chain with that as 1. And so you could say that we have a chain there, and this would be both of these cases. So this is 1, 2 carbons. 2 carbons, we're dealing with an ethyl. We're dealing with an ethyl. And on the first carbon, you have a methyl attached to it. So you could also call each of these groups a 1, 1 methyl ethyl instead of an isopropyl. So you could either say isopropyl for each of these groups, or you could call each of them a methyl ethyl if you do systematic naming. Now, you can't, well, you don't, we have two of these 1 methyl ethyl groups, just like we had 2 isopropyl groups. If you're using common naming, you can say diisopropyl to say you have 2 of these groups. When you're using systematic naming, you don't say di 1 methyl ethyl, although that probably would get the point across. You use bis. So this is, since we have 2 of them, instead of writing di, you write bis. You write bis 1 methyl ethyl. That means you have 2 of these things right there, and it's still in the 4 and the 5 position. And if you look at it in alphabetical order now, methyl ethyl comes after methyl, right? So the order will now change. So now, if you want to write it with systematic naming, it would be written as 2, 2 dimethyl, that's these two guys, 2, 2 dimethyl ethyl, and then you would write this guy. So the order changed for the two groups just based on how they're named. Bis, and then over here, you have 2 1 methyl ethyl groups. I know it's confusing, but when you just break it down, it actually makes a reasonable amount of sense. You have 2 of these methyl ethyl groups. Oh, sorry, I forgot where they're located. So we have them at the 4 and 5 position. So in the 4 and 5 position, 4 and 5 position, we have 2. So bis, we have 2 bis 1 methyl ethyl groups. Methyl ethyl. I know it's a little daunting now, but it all makes sense when you break it down. Methyl ethyl groups, and then we can just add the octane at the end. Octane. Let me scroll over to the right a little bit. Octane. And we're done. Now, this might seem more confusing, but when you break it down, it makes sense. We have octane as the backbone. We have two methyls. They're both sitting on the 2 position. So you have two methyls sitting on the 2 position. And then you have two 1-methyl ethyl groups sitting at the 4 and 5 position. So in the 4 and 5 position, 1-methyl ethyl. 1-methyl ethyl. You have an ethyl, and in the 1 position, you have a methyl. So that's all it's saying. Or another way to think about it, just in case this doesn't confuse you enough, you could call it that, or you could say 4, 5 diisopropyl. These two things are the same thing. Common naming, systematic. Hopefully you found that useful.